Welcome, everyone. Today's general interest seminar, we'll talk about the Gaussian16 and NBO7 on computer Canada clusters. My name is Jamie Hu. I'm a Chocolate HPC consultant, and is also part of Computer Canada. I'm based at the University of Waterloo. So over the years, I'm supporting Gaussian users on chocolate clusters and on computer clusters in general nowadays. So this seminar is basically is a brief review of Gaussian, and then we introduce the new NBO7. It's a separate package, and we installed with the latest Gaussian versions recently. So the hope is actually, we hope, we saw all kinds of problems, and in general, Gaussian users are very good users and follow the instructions to how to run Gaussians on the clusters. But still, we hope you have a much better understanding, not just through job on the cluster, but understand how does the job running and background, and the possibility to manage your files much better and to make the clusters more efficiently. Okay. So Gaussian on Computer Canada clusters right now is only available on Graham and Cedar. That's because Gaussian is a commercial package. It's a licensed software, and also it's a site license to specific site. So for example, Chocolate has a license, and the license allows it to use for systems at the site is University of Waterloo. It happened to be Graham is on the site. And then Westgrid has a site license as well, and allow us to run that site license at SFU. That's where Cedar is physically located. It's unfortunately, Gaussian is not available on other Computer Canada clusters because those clusters are on different site, and until those site, they were willing to purchase their own license. Otherwise, so we cannot put a Gaussian on those clusters. So that's one thing. So I think all of you are aware of this. So if you don't like to run Gaussian, you either go to Graham or you go to Cedar, or you can do it on both, but not on other clusters. And then software installed as a module package, as with all other softwares installed in the common place. So the basic command, we use module command. So if you use module where you can say all the software is available on the cluster. And you use modules by the software name, like Gaussian, and you can find what's available on the clusters. So right now, you can go to either Graham or you go to Cedar. They're exactly the same package, the same installations. It's basically a copy of each other. So we keep a few versions there. So because still user asked us to keep all the versions on the system. So we still have Gaussian 03, and then we have Gaussian 09. And then we have Gaussian 16. 16 has been there for quite a few years already. So we have starting from A, B. Now the latest is C01 version. So that's the latest. It actually has been quite a few years already. So to Gaussian's tradition, so it normally the minor version will all the way go to E. So we can find we know that the G09 there is E. So it's supposed to have following Gaussian 16D or E or something. Maybe because of the COVID, so it's getting delayed. So when you run from command line and you simply do module load Gaussian, and then it's the virgin. So I think you know that as well. Okay. So on the cluster, unless you, for some testing, do interactive jobs, otherwise all the jobs will start from a run script. So we call it it's a Slurm script. So you understand it is pretty much do three type of things. The first thing you need to specify your counter type. Each of you will have a default per group. Like mine is my default account. And some of your group, you have a rack allocation. So let's a higher priority account. So you would like to use that. That will be good for some of you. And the big part of the script is to specify the compute resources you need for your job. It's like say how many CPUs to use, how much memory to use, and how long your job is expected to run. So this type of things has something to do with the job type. For example, it's MPI job, it's OpenP job, or serial job. Gaussian basically software itself, it can run in serial, use one CPU by default. But Gaussian is an OpenMP type of code. So that means it's a shared memory code. So we have explained it here, and it basically can only run on CPUs on node. It cannot cross CPUs, cross different node. So that's a basic knowledge about to understand Gaussian for now on computer Canada clusters. And then the last part is for say your load, to do the module load and to load the right versions to use. And then is the command line. And I have an example show here. So a little bit more about that shared parallel code for Gaussian. And the Gaussian is actually has a Linda is another approach to do parallel. So we talk about parallel is basically we use more CPUs to run one job. So let's approach to actually to use more CPUs. So to run Gaussian cross loads, but we don't have the license, so we don't have that approach. So all you understand, if you want to run Gaussian on Graham and Cedar, you can only use the CPUs on one node. You don't want to try to cross load. Okay, so default still use, so you don't need to specify it. Default is use say a serial job on one CPU, and it's still good if you say you work for small molecule. And the shared parallel is how many CPU to use. So it's basically, you can use the CPUs basically say starting from 2 all the way go to the maximum CPUs on that load. On Graham and Cedar, originally or majority of the node, they have 32 CPUs. And now they have some new node, they have different types. Some of them, they have say 24 CPUs, some of them have 40 CPUs, some of them even they have 48 CPUs. So now with a different load structure, so the maximum CPUs per load is different. But pretty much is say each load, the structure right now pretty much is 2 sockets. 2 sockets is say for the 32 CPU nodes, is 2 sockets. Each socket has 16 CPUs. So OpenP and the Gaussian is type. So if it runs for CPUs on one socket, it runs the most efficient. So let's on our wiki page, we basically recommend, say you use 16 CPUs to run your jobs. 16 CPUs is pretty much good and for most of your jobs. But certainly, and for some smaller jobs, you can use 4, you can use 8, or all the way you go to the maximum if you really have a big molecules. So here is basically the simple data run script. So it's a count type, and then here say because Gaussian is a shared memory job, you can specify the total memory is --MEM for shared memory job. Yeah, it's not memory per CPU, it's the total memory. And then it's a number of CPUs per task, because Gaussian is runs as a one task, but it's run on multiple CPU, multiple threads. That's the type, right? And then you can specify the output on an output. And this output is not Gaussian output. This output is basically for any message and any issues from the system, from Slurm system, like a crash, like a whatever, memory or some other things. It will print any messages, print on screen message will go to there. And actually Gaussian itself, we have a script with a code. We use it, it's a capital G16. That's a script we made. And we made that script is just for one purpose. It's redirect all the runtime files to your Scratch directory. Okay, and then we define the output file to be your lame.log. So you simply type G16 and this capital G space, and for example, your lame input lame is this lame.com, and then your output file name will be a list.log. Yeah, that's what the script capital G16 does. And then you don't need to necessarily need to use the capital G16. Instead, you can actually use the lowercase G16, and then you actually import is this import file, and this is basically tell you it's input, and output you go to this type of output file, and then well this and is basically the overwrite right from the beginning. So using this is also fine. I will explain this, what's the difference, and in the slides afterwards. So once you have this, and you have a .com input file, and you have this type of called data is a bash.sh file in your job directory. And in your job directory, you submit a job, use sbatch. Sbatch, you submit a .sh file. Certainly you make a .sh file to be executable. Your first time is not executable, you need to change the file to be executable file. So your job will run, right? So this is the common sense, so the world know about it. And then we continue to talk some basics. And some basics, as I said, the latest version is G16.C01. And then the resource request is the memory, is the CPU, is the time. So the memory is there, and I think we go back. The memory is there is actually said how much memory. So memory, the size you specified here has something to do with the memory you specified in your input.com file. So normal case and is roughly this will be the double the size of your specified in your input file, the memory. And then the other one is you need to make match. Is whatever you used here should exactly be the same you used in your input file if you specified the number processes to be used. Gaussian will use whatever you used in the input file. So if you use the input file is 4, and then basically the cluster will give you 16 CPUs, it's actually 4 CPU going to work. And then you basically, the other 12 CPU will not work. So this need to be matched. So these two things need to be, you need to double check. So I think some users will, maybe forget it or change it without pay attention to it. That's what we observed often. It's not consistent there. And then in the file, I think you need to understand where your file will stay and what files you need to limit yourself. So we'll start with simple examples. And and to let you to understand it a bit. And then we talk about a little bit of restart. And then we again will specify use examples to say the scratch or the local, the file, the disk. And then some utilities like your form check or something. We do have try to put everything on a Gaussian wiki page. And I think all of you have read through the wiki page there. And some of them may, I think this is seminar will help to understand it. The Gaussian files, as we said, were input file, and normal case where is a .com file. Some user will like to use a .gif file is also fine. So basically it's a two type. And then is run script, and output is .log file, right? That's all supposed on same file direction. You record it the current Java directory. And the random files, Gaussian will have 5 files. And the most important thing is .r. WF is called read-write file, read-write files. So these are the files super important. And then the other files, certainly they will stay there pretty much. They are empty, they are small. Well, little file name. So if your job started with the capital G16, those files with a sort of Gaussian comes with a Gaussian's name, and then will stay in the job ID directory until scratch. So if you want to find the files, you go to scratch, you use the name and the job ID, you can find them. Okay. And then if you use lowercase G16, your file is not go to your scratch. Instead, it will stay on the local disk on the load your job is running. So it's called a local scratch. The local scratch, and then if you go to your local scratch, and if you go to the load, your job is running local scratch, and then you find your username and the .job ID .01. So your files are there. Okay. So Gaussian users will actually recommend you always name your checkpoint file .check, or sometimes your .rwf file. And then in that case, you know which job you're running. And these two jobs are important for you to restart your work, restart a job in case your job is failed for whatever reason. We'll talk about that later, okay? And certainly the cluster will give you an option to run interactive job. And for testing purpose, some of your particular new users, you are not quite sure your input will work a lot, and you can do a quick test without waiting in the queue. You can actually run it from command line. So Slurm cluster on Graham and on Cedar use slog to basically reserve the computer resources for you to do the interactive job. So you specify how long time you need to use. The maximum time is 3 hours. And then you say how many CPUs, and then you say how much memory you need to use, and then is who you are is your account. So that's what basically is the thing you ask that you put is a part of your Slurm script there, right? So after this command, and you wait for a while, you can see on screen you are basically allocated to a load, a specific load. You can do work from the command line. And then you simply type a module load, say G16.co1. And then from the job input it, you simply type it, right? You basically is a script, you type it, do it. But this is only for a testing purpose. And it's not supposed for regular job, right? So we go quickly and from the most of the simplest input, and for the way you can manage yourself. So Gaussian import is called as simple as this. It's basically a command line. It's a keyword line, right? What type of method you use, what base set to use, what are you going to do? So in this case, we use B3LYP, the DFT method, and this type of base set. And we do optimizations and do frequency calculations. And then whatever called the whatever molecules there. Gaussian, you remember, and always in the last line, you need to keep a blank line. And it doesn't matter what, and you always need to keep it, and otherwise it will go through error. I think many of you saw that when you're new to Gaussian, right? And then so this will run, and then you submit, you run it, and it run one CPU, and then the memory will be default, and is either is 256 or 512 and megabytes or something. I didn't pay attention to the changes recently, right? And then certainly, for the default memory, and sometimes it's too small, and those days is certainly too small for most of calculations. So then you can define how much memory to use. For example, say I use 5 gig, so that pretty much is more than 10 times the default. Right, and then you say, I can use multiple CPUs. Use these two, and percent sign MEN and this NPROC is number processes. Specify, so you can use 4, 8, and 16, all the way go to 32 or something. So this is basically 2 things you can add to it, right? And then instead of that, if your job failed and the job failed, it's gone. So it's always good practice, and you specify a checkpoint file. And when you specify checkpoint file, when you run the job, you have this file and input.check, and you start check in your job directory. And when your job, for whatever reason, power outage, whatever reason, and or run out of memory, part of reason your job failed, you can use it to restart a job, restart for optimization jobs, right? So you can do this. And furthermore, you can name your own RWF, your read-write file. And then if you specify it, and in this case, normal case, you add a no save option. When you no save, that means when your job finished fine, completely correct, the RWF file will be removed automatically by the system, by Gaussian. Otherwise, the job will stay there for you to be able to restart it. Okay, so when you name a file here, unless you give it a full path, otherwise, so the file will be created in your current job directory. Okay, I think you know that. So checkpointing is important, say, because sometimes the runtime is short for your job, and then your job is stopped in the middle. Most of the time is because of all kinds of reasons. So you can always restart your Gaussian jobs. You don't need it to run from the very beginning. You don't need to. It will save some of your times. So you have 2 ways to do it. For the optimization job, optimization is always a multi-step calculations. So you start from the checkpoint file. It's the easiest way to do it. And certain checkpoint file, can you say you do optimization, you have a checkpoint file. Afterwards, you can do a separate calculation, like I say, frequency calculations without go back to do the optimization again. Or you can use checkpoint file, you can transform or something. You use it for Gaussian view, do visualization, all kinds of things. So checkpoint file is important. Okay. And then in Gaussian16, the read-write files is quite good for restart any type of jobs. And particularly, frequency calculation used to be one-step calculations. It cannot be restarted from checkpoint file. Now it can be restarted from RWF file. So that means even you're in the middle of the calculation, frequency calculation, the job failed, and you can restart it. So I think that's you at least you need to know how to that options. So the input is actually for restart is quite simple. And if you do optimization job restart, whatever you input, and you simply just keep the keyword 9. You have the keyword 9, and then you simply add geometry equals say input is all check, and guess from read from checkpoint file. You don't need any further. You just leave one black line there. That's it. That's for to restart an optimization job. If you start from a frequency calculation or something else, for example, and then you have to restart job from the .rwf file. You need to specify where is that file. So it's basically restart from which rwf file. Right here, if it's not in the current directory, maybe it's still stay in your Scratch directory. You need to give a full pass for that, and then you simply say restart, and the new one black line. So in this case, your job Gaussian will try to read everything from this read-write file, and then basically have the read-write file has all the informations there, and then we'll try to restart your job. Okay, so restart job is just like that simple. And if it's for whatever reason, it's a disk problem or it's a memory problem, you can change that. You can change the memory to a different memory, right? And in the script, you can change it. Okay. And then furthermore, what I want to emphasize is here, it's about the disk, the file locations. As we said, there's two options. One is you start a job with capital G16, and the other one is you start with use the traditional, it's lowercase 16. So what's really the difference is the location of your runtime file. So you will know for its capital 16, the runtime file is on your Scratch. And then for the traditionally, so we set up a temporary Slurm directory. It's the local disk. So you need to understand local disk. Local disk has a disk, and normal range is in 800 to 900 gigabytes. So new Slurm is reasonably good, and will be good for pretty much most of the Gaussian jobs running right now. And then because it's right to the local disk, so the speed is should be fast. And how much faster we don't compare, but should be theoretically, right? So for big jobs, if any jobs is over say 800 gigabytes, and then the disk size, is not enough. So in that case, G16 will be is your only options. So we talk about that is basically we talk about that is your read-write file are saved there, because all the runtime files basically is the size of your read-write file. Okay. So the difference is say, when your job is done for whatever is failed or is succeeded. So your files on your Scratch, if your job is failed, all those files will stay. It's still there. Okay, and if your job is completed, so all those files will be removed by Gaussian. So you still have a job ID subdirectory, but it's empty there. However, for any files saved on the local disk, whatever reason your job is gone, all the file will be removed immediately, because you need to new space for other jobs. So the job will gone. So in this case, so each of them have a advantage or disadvantage. So the advantage is, say, potentially you'll be use the local scratch, the job will be faster, but right. However, because it doesn't save any files, so if you need a job to start, first job to restart from read-write files, and then in this case, no, the file was gone. However, if your job is saved in your scratch directory, your job is still there, right? Your file is still there, so you can use it to restart. Okay. So in that case, is say, if you don't need the file, certainly there's other thing you need to clean it yourself. Okay. So let's say, and this is a diagram. So when you work, you only unlock a node, you see anything, but your job is actually run on one of the node, right? And the disk array is basically huge, the scratch patterns there. So you have a communication between nodes and the disk outside of the node. The disk onboard disk certainly will have better performance. So the job location is basically like that. And then you have the other files is on the work directory. Okay. So here, I think we don't need to spend much time here. It's basically, I actually did a test, and on the other day, I submitted to the same job, and basically use a capital G16 or localscratch, and it's run on 2. So when you have the 2 basic job is running at a time, you can go back and check. So this is run on the load Graham 766. And I can go to 766 and go to the local scratch. You can find, and this is the job ID. You can find all of the Gaussian data runtime files there. And you can find where it's actually, the file is stay there. So when job is done, is finished, all those files will be gone. And then the other one, you can find the job ID. You go to my scratch, and you can find we have a scratch subdirectory there. And in this case, we don't have that, right? So let's tell you when your job running, use different command where they are. Okay. So the common problem here, I think maybe it lasted quite a while for a while. The most common problem we saw is you have a run to disk error. So your condition error is basically give you the message. This is the message is at the end of your data log file. This message is thrown by Gaussian software. It's not by the system. It's basically tell you you're right. You have right problem, and the normal case is basically the disk is not enough. So let's level 2 things to address this situation. You can do it all by yourself. If you understand the questions. So first say is normal. If you run, you use your like you use lowercase G16. That basically tells you your local temp that a local scratch is not enough, doesn't have enough space. So you switch to G16. And if you say that type of error, you use G16. What it does mean is actually, scratch, even though you can go to several terabytes, but it still is a disk array. And the disk is still, controlled by the disk, the server OST is controlled. Each is actually has limited size as well, but it's a big size anyway. So if you still get that, so space is not enough or whatever thing, and then there's a way user said on your side you can do a set scripts. So the RF is command set scripts. So you can basically use save your file to over multiple OSTs. For example, default, you say I said 3 my Gaussian runtime files scratch to 3 different OST files. That basically give you more disk space and often can fix the problem there. Okay. And then is the Gaussian utilities. So Gaussian utilities has quite a few. The common one I think used is form CHK. It's basically CHK is on the cluster is a Linux format. You want to transfer it to Windows format. You can use it, and you can generate like a Kuba game, and you can frequency check or something. So the only thing I want to mention here is you need to use the exact same version. You can run this command from command line. You don't need, because it's quite short, and you don't need to submit it as a job. And then what you need is use the exact same version. Otherwise, you will get errors. Okay. So I think that's the basic review about Gaussian. And then we have a Gaussian wiki page. You go to Computer Canada and you go to check. I think we have explained that, but sometimes maybe the example are bad or it's not updated and not always good. It's quite likely. And then the Gaussian, the Gaussian.com is the software website. There is user manuals, there's a keyword list, everything is there. We are here to support Gaussian to run on our clusters. So we'll make sure Gaussian will work fine on the clusters. And then on top of that, we try a little bit more if we can and to help you, like address some input issues, like address some restart issues or something like that. But a package Gaussian is complicated. There is something, maybe there's many of them we don't know. And if you really have something, sometimes we ask you to actually ask for Gaussian directly. And those guys, they made the software. They will do much better. They know everything. Okay. And then we talk about the other is called lateral bound orbital, NBO. NBO used to be part of Gaussian. And at some point, they want to a little bit more money to make it to something like that. And you separated the license. So we needed to make it work with Gaussian. So NBO perform is the analysis of many electron molecule wave functions in terms of localized electron pair bond units. So it's basically chemistry. We're all chemists, so we understand that it's for chemical intuitive and for the Lewis structure we are familiar with. So it's a good thing. But it's a post processor after Gaussian or after other computational chemistry packages. It's actually do a sort of transform of the wave function to be localized, paired bonding something. So there's many of things transforms there in NBO's output. They have NBO's lateral atomic orbitals and lateral hybrid orbitals and lateral bond orbitals. That's the final name used here. It actually has a lateral localized molecular orbitals as well. And they use this sort of information and to perform a lateral population analysis. And then they do energetic analysis and they use some lateral resonance theory or some natural chemical shieldings. I'm not quite familiar with this. I just know the basics. So I think the most important thing for us to need to understand is what's available here. So what available here, Gaussian has a default built-in is the 3.1. So you don't use it because it's out of dated and it's not reliable anymore. However, if you don't know it, you just simply say you use a keyword, say pop equals NBO, they still use the default one. Okay, but you from output file, you should know it. So what do we have right now on the clusters? So on G09 on the G16.NBO7, they still have NBO6. And then recently we have NBO7. NBO7 makes it work with the latest G16.C01. So that's why NBO7 is only available in the latest .C01 version. because it doesn't work with the previous versions. Okay. So anyway, we always recommend you to use the latest version. If you run Gaussian, always use the C01, or if you want to use NBO, use NBO7, right? And there are some new, say, NBO7, and I think the most important thing to me to say it is basically is add a function is say they call it AEDA for Gaussian. It's called lateral energy decomposition analysis. This is implicated for Gaussian, this latest version specifically. And before that, and Gaussian does not support these changes. However, we know like MSA, traditional ADF package, they have NBO. The NBO is built, and ADF, they purchased the NBO license and they built it to ADF packages itself. Gaussian didn't. There are a bunch of others, and if I'm interested, you do check it. I'm not. Okay. So the most important thing for us is to do the simplest import, right? So this is NBO7 is supported. So you want to use it, and keyword 9 is for the populations. So say you use pop, you expect pop equals NBO7, it will calculate for bound, natural bound analysis. Okay, there's some others. You can find it. It's like NBO7 read, NBO7 delete, and if you do that new natural energy decomposition analysis, you have to specify NEDA. So this is in the keyword in the Gaussian input keyword. And at the end of the Gaussian input, you still have the options and to add the NBO input combined with NBO input. And the NBO input comes with a K-list, and it starts with a K-list and end with end. And in the middle, you can put something there. Okay, so the main NBO K-list is also like this format. So for example, we will do dipole and we'll do NRT, and it's NBO stat like this. And then if you can have more, you can define your files, NBO files, and you can archive it. You can do some other things. You can also put them together. It's a block. And then there are other K-list. You can check the menu, and they have a course, they have choose, they have some others that delete. And then the thing is, each NBO always comes is like a each has their own electric block. You can actually each will come with the NBO is a K-list. You have to end it, and then it's come and say this is to delete, and delete what, which element or which pair, and then you end it. And then at the end is a blank line. And that's all, because this is at the end of the Gaussian input file. I think I have quickly show you examples. So here is basically the default. So we do whatever optimizations, and we specify the NBO7, and it will default. It will do after the Gaussian calculations, will do NBO7 calculations, has all the input and just this is simple, and then has all the output files. And then you can be a little bit more like this, or do the similar optimizations, and then we can use a little bit more different keyword. And then in this case, say, in this case, we don't want the output, we just want to say the summary, and then you can add this. And then you can choose, say, it's no pair or bound, what type of bound. And you can do the choose K-list. And you can say perform deletions analysis. You can do delete or do noise or something. So there's also you can check yourself. So when the job is done and you go to check Gaussian's output file, .log file, and you can find this NBO 7.0. This is output file. and then this is title, and then there's how to cite it, what blah blah, and then I got to find where is your files where or something, and then start with what type of jobs, and start with natural atomic orbital occupation, and there's blah blah. There's a bunch of them by default, and at the end, it's a natural bound orbital is a summary. The summary is basically each atom is like this is a core, it's no pair, or it's a bonding, or it's a long bonding, or something. And you'll understand that. I have some examples in my directory. You can check it. And certainly, the final resources is you go to NBO website, the NBO website. They have a manual there, and then they have some updates. They have tutorials there as well. Okay, I think I will stop here, and we'll leave some time for you to ask questions. If any questions or any suggestions, feel free to ask.